What's going on, you guys, and welcome to my second YouTube video. We're going to be continuing from where we left off in the last one, and that was where we focused on the single responsibility principle as part of the solid design patterns. And so in this one we're going to be doing the open close principle, which, following the acronym SOLID, is the next one. And this one is like I guess slightly more complex compared to the single responsibility principle. So yeah, we'll start with this, and hopefully by the end of it, the example that we work through will have given you like at least the gist of it. So the definition of the open close principle is that software entities should be open for extension but closed for modification. So yeah, like at first when I heard that, it was quite okay. Like the single responsibility principle was a lot easier, as that was just like a class should have one and only one reason to change, which is a bit more straightforward. This you're kind of expected to understand what it means by extension and modification. So to translate this into the real world, let's say you're a basketball player and you're very good at your game, and one day you decide, oh, you know what, I want to learn how to play the violin. So you go out your way and you learn the violin, and at the end of a few months you can play a few songs. So what you've done there is you haven't modified your basketball skills. Like, your basketball skills are still as they were before, given that you'd at least practiced. But the point is, like, they don't affect your basketball skills. And so you haven't modified your basketball skills. However, you have extended your overall skill set. So yeah, like now you can play basketball and you can play the violin. And yeah, that's kind of like a loose sort of like example of it. To translate this into code, what it means by closed for modification, or software entities closed for modification, say that you have a class that comes from a third party, or a class that's like is depended on by a number of other classes. You don't want to modify that class, as it can lead to unexpected behavior. So you've clearly defined this class, whether it be a car class or like an email class or whatever, and that has, yeah, the definition of that class has been solidified. So you don't want to modify how that works. So therefore it's closed for extension, because it could lead to breaking changes. That's one reason. Another reason could be that, let's say you're working in a team, and you change a class that like the whole team depends on. However, you haven't like translated that to other people within your team. Then it can lead to some confusion, but also it can lead to breaking changes. Like wherever that class is dependent on, you can't count on yourself to know like all the places where that class is used. So there could be breaking changes elsewhere. So that's what it means by closed for modification. Open for extension, however, means you like, in order to add extra functionality to your code or to your app or whatever, you can use that email class, for example, that we just gave, or like whatever class that you're using and don't want to modify, you can extend on that. So by that definition, you can use that as like a parent, and then like use that as a and then add functionality there. So might be better to just quickly show how that would work. So let's say you have a sum class, so like the parent class, and this just like is used in many places, and yeah, we won't add any functionality there. And then let's say like there's a number of like functions or methods associated with this class, and that's what you don't want to change, because is this used in many places. So if you change anything here in the places where it's used, it could break those areas there. And then you can have like the child class, which now, like, this is what it means by open for extension, or an example for open for extension. You can now like override like anything that like the parent class does. So you just override stuff in parent, and that way you can add new functionality. So for this example, we're going to be creating, let's say, like a very basic filter for countries. So imagine you're working at Airbnb and you want users to filter by the continent and language of a country. Yeah, so it's going to be very basic. There's not going to be too much like implementation in terms of like the classes themselves. And yeah, we'll start off by importing enum as enum, and we'll create a very basic continent class which will inherit from enum, and we'll have Europe, Asia, and Africa. And then we'll do the same, creating language, which will have English, German, and Arabic. We'll create the country class, which will be very, very simple. It'll have name, which will be of type string. You'll have a continent, type continent, and language. Yeah, one thing you may have noticed is that like I like using typing in Python. If not technically typing, that's more of just like preference for me. You don't have to do the whole like specify content as content, continent as continent, or language as language. It's just something I've grown used to. But yeah, so we'll just do the standard stuff for creating the constructor for our class. And continent and language. Okay, cool. Yeah, so we'll first break the open close principle and show you how why the open close principle is quite advantageous to use. So we'll do class bad filter. And so here, yeah, there's not going to be much aside from just implementing functions inside it or methods inside it. So we can do filter by language, and we'll give that a list of countries. Just import. And we'll also need iterator, which will just be a list of country and language, and this will just return an iterator of country. And so for country, in countries, if country dot language equals language, then yield country. We can do the exact same thing for continent, so just copy this and say filter by continent. Instead of language is continent. And so if country.continent is equal to the continent that we want, then we can yield country. So yeah, that's filter by continent and filter by language. We may also want filter by continent and language, which will be we're not going to implement this, but yeah, there'll be that. And so that's one other thing we have to implement. And then of course, aside from and, we also need filter by continent or language. So these are things that you may want for a filter, but like from what you can see, we've created 4 filters for just 2 data points. If we were to add like another data point, let's say like a population size being small, medium, or large, then we'd have to create another filter by population, and then filter by population and continent, filter by population and language, or population or language or continent, and then all 3 of them together with and ors. So it's just growing exponentially the more that we're adding, and this isn't good. Because it's just a lot more code to write that's needed just for something as simple as a filter. Like from that perspective, you can already tell that it's bad code. Other things as well, like in terms of the open close principle, we're modifying this class, so we're modifying its behavior by adding more and more filters, which is what we don't want. As well, like if we were to create the filter and have that as a dependency to other classes, then we're just adding more and more things that this class can do that shouldn't be added anymore, as this class should be well defined by that point. This is what we want to avoid, we have to avoid, really. There's no other way to put it. So the workaround this, so to kind of bring this back in line with the open close principle, we can start by creating a specification class. And this is just a base class, so like a base class, actually put it as dot code, so base class to be inherited, and this is where we're extending it, or we will be extending this specification class. So we can create is satisfied, which will take in a country, and and that will return a boolean. And so we can also do we can also create a filter, which again will be a base class. Take that, and this will take in a list of countries, and will return an iterator of country. And again, this will be overridden. So we can start by creating actually I want to know why this is complaining. Is it complaining? Is there a reason why this is blue and this is yellow? Oh, we'll see. Just run the build principle. Yeah, okay, yeah. Yeah, nice, and same here as well. Okay, cool. So ignore that part. So we can start by overriding the specification class, and we can create the first one that we created was continent, so we can do continent specification, and that takes specification, and we can do is satisfied and self country, return a boolean. Actually, before we go into implementing this, we need to add the constructor, and this will take in a continent. I'm going to say self.continent. Continent. Yep, you can tell my typing isn't at its best today. So we can do return country dot continent equals self continent. Cool, and we can literally have that as an example of language. So we can do language specification and say language. So language, and finally language. Yeah, so we've created the continent specification and language specification, and now we can create our awesome filter. We call this the better filter, which overrides filter. And so with this, we're just overriding filter from this, and that should be named filter. And that takes in a specification. Just a specification like that. And so filter, and then countries being a list of countries, and also the specification being specification, and this will return the iterator of country. And so yeah, so what we'll do now is we can do for country in countries, if specification dot is satisfied by country, we can yield the country like so. Okay, so now if we set up this, so we can create like a bunch of countries now. We can do England, continent, continent like that, and Europe, language, English. We can do this a couple times and say Germany, German, do Egypt, Africa, and Arabic. Okay, so we can just create our list of countries like this. So England, Germany, and Egypt. And now we can create a, let's say, a language specification. So we want lang spec being language specification, and we can pass in language dot, and we want all countries that speak English. So we should expect England, and we can create the filter. So better or BF equals better filter. So now if we do for country in BF dot filter, and we can give it the list of countries, so countries, and the specification being language spec, we can print country. So if we run close principal, yeah, we do country dot name. So we get England. What we expected as well, as that is the specification we asked for is the language specification. We want English, and so we're just getting England. Now we could also create like a continent spec. And we can say continent specification, and that taking in, and we want all continents that are in Europe. What we can do now is just simply change language spec to continent spec, like so, and we should expect England and Germany. So yep, England and Germany. Cool, yeah. So right now it seems like quite a bit of code to replace that. But if you try and imagine it in like a very complex application with like many different filters in this case, then it becomes very like useful. So if we were to create like the population class or that as a data point, all we'd have to do is create the population specification and then just create that there, and there we have it. So there's one last thing I want to show, and this will really show the beauty of aligning yourself with the open close principle. So if we revisit the bad filter that we created, so what we've done already with like the with this is we can implement the filter by language, filter by continent, and if we were to do population size, we can do that as well, or any other data point. However, one thing that we do want to have is filter by continent and language, and filter by continent or language, or filter by and or. And yeah, this is where like it will really show like how great the open close principle can be, and doing it this way can be. So what we can do is we can create the and specification. Like so, just again inherits from specification, and create the initializer. And this will just take in arguments, like a number of arguments. So it could be a number of different like and or specs. And so this will be self.args. Args. I'm also going to skip out on like the whole typing and not double down on that too much for the sake of time. So we can self is satisfies. We override that, and yeah, we'll basically just pass in the country, same as usual, and we can do a nice use the all iterable, and then map, and then use the lambda spec.is satisfied, and that just takes in the country like that, and we just pass in the arguments. So, and the final step is just to override the built-in and class method. It's great. One of the things I love about Python is just the simplicity of having something like this and overriding that. And this is where we just return the and spec along with other. So now, if we go back and let's say we want, or the user wants to find a country where the spoken language is German and the continent is Europe. So we can create another German speaking country, so like Austria, and there we go. We just add that into that. And so we want German. Now we can create a combination of these two specifications. So we can say German, Europe spec, and all we have to do now is just do language spec ampersand continent spec, and there we go. We have that specification. That's it. Which is way more convenient than having having to implement something like this, which is just really cumbersome. And yeah, like now you can see, like hopefully you can see the benefit of doing it the open close principle way. So instead of continent spec, we can do German Europe spec. Save that. Python 3 open close principle, and there we go. We have Germany and Austria. Cool. So the final thing would be to just add the OR specification, which will be done so similar to how we did the AND specification. That. And we can literally just copy this over, to be honest. and instead of all we can do any. And here we can say, let's copy that and do or. I think it's or, is it or that's usually like the, yeah, okay, or specification. I always get mixed up because I feel like sometimes like it's different, but yeah, I guess or's fine. And yeah, we just, yeah, literally do the same thing. And what we can do now is, let's say we want a country, I don't know, what combination could we have? Let's say, for example, let's say Egypt speaks English, right? What we could do instead is do English. Actually, it doesn't really matter in this case. So we can do English or Africa spec. So, and we can do, let's say the language spec is English, and the continent is Africa. So now we can just do lang spec or continent spec, like that. Let's comment that out for now, and let's put English Africa spec, and there we go. We have England that has English, and we have Egypt which aligns with Africa. That's it. That's as like it's you can, I think you can really see the beauty afterwards, like when you have stuff like and or, and as you can see, we're not changing specification itself, like we're not adding more functionality to it aside from these. However, they're very abstracted away anyway. Like these won't change, the behavior will be expected. Like I wouldn't go around changing something like that, but what we're doing really is just we're overriding or inheriting from specification and adding our own features to it. So like the continent specification checks for continent, the language one checks for language. We're not changing specification itself, we're just extending it. And the same goes for filter. We could have different filters. Like it may not be country, it could be cities, stuff like that. Like it's yeah, that's really it. So yeah, I hope this video was of some value to you. All this code will be on the GitHub link that I'll put in the description, so feel free to check that out. And yeah, hopefully I see you in my next video.